Hello and welcome to another video. In this video we're going to be working on Defuse the bomb and we're going to be doing it live, so let's see how it goes. So in this one you have a bomb to defuse and your time's running out. Your informer will provide you with circular code and length k. To decrypt the code you must replace every number. All the numbers must be replaced simultaneously. If k is greater than 0, replace the ith number with the sum next k. If it's less, previous k. If it's 0, replace it with 0. Okay. Circular, yeah, so basically it just like loops. Okay. Given circular code and enter k, return the decrypted code. Okay. So here we replace the 5 with this, which is 12. Then we replace the 7 with 1, 4, and then 5, which is a circle, which is 10. Then we replace the 1 with 4, 5, 7, which is 16. And then we replace the 4 with these 3, which is 13. Okay, 0, all zeros. Then negative is just, it's just the previous, previous k. Okay. So for 2 would be previous 2, which would be 12. For this, previous 2, which would be 5. For this, previous 2, which would be 6. For this, previous 2, which would be 13. Okay. Okay. So definitely looking at these constraints with n is 100 and k is 100, I guess. We can definitely do this with like a brute force where we can just go for every number and then calculate. But the thing that's going to happen is, I think, like for 5, like let's look at this example. For 5, the next 3 numbers are like 7, 1, 4. But now for 7, the next 3 numbers are 1, 4, 5. So you see kind of like only a few of these numbers are going to change. Like for each number, one of these numbers will no longer be in this sum, and then another one will be added. So I think what we want to do instead is we want to maintain a sum, and then we can just like get rid of the last element and add the next element, kind of like a window of like the next elements. We should be able to do that. So I think what we can do is we can calculate 3 things. The left index of our window, the right index of our window, I guess maybe a few more things, and the total. Yeah, I guess that's it. And then we're going to calculate this for the first element, and then for the next elements, we're just going to be going left or right. I guess we're always going to be moving to the right, right? Like, for example, for this element, the previous 2 elements are here, and then for this element, the previous 2 elements are here. So we're always going to be going right. So we're going to calculate these 3 things. And then as we go to the next element, we will just basically add 1 to both of these, and then get rid of the element that used to be here and add the element that is, at the new location. So let's do that. So we're going to say int left, int right, and int total. And we're going to make this result of length k, or length code. I think if k is 0, we can just basically fill this out with zeros and return. So let's do that. So we don't have to worry about that case. Yeah. And return. So that case is done. Now, if k is negative, where's our start location going to be exactly, I guess? So it's going to be so if k is like -3 or something, our start location will be this index -3. So that'll be like here. But I think this is the same as this. We'll double check this. So I think it's like code length plus k. Let's look at a couple examples just to see what I mean. So if k is like -1 here, then the start number is going to be here, which is at 3. And -1 would also give it the same. If k is -2, the start index would be here, and that would be, so this would be at index 2. And this would also give us the same number. If k is -3, our start index is here, which is here as well. So that's how you convert from a negative to a positive. You have like negative Python indices that you can convert to a positive. It's pretty simple. You just do this. Okay, so now we have a starting k location that is, basically we have a starting location. So now we basically want to loop from the start k times and get a total here. And then we want to do the circular array. And because we're always going right, the circular part is pretty easy. Our index, we can just mod it by the length of the array. And then that will always give us a like never out of bounds. So we can do this in a one space. The other thing you could have done was you can actually make 3 arrays. So you can have like new array here, and then like this. And then you can use this for the indices, and then that way you're going to make sure you're never out of bounds. So you just iterate through this index length, and then whenever you go back to these, basically, yeah, you're never going to be out of bounds. So you can go here -3 and you'll be in this array. You can go here plus something, you'll be in this array. So that's another way, but we're going to try to do it in O1 space just to make it a little bit more complicated. But yeah, so now we're just going to walk through this array. We have k elements no matter what, right? So yeah. And then maybe we can even get rid of this case with our new solution, but we'll see. So int I equals, how do I want to do this? Yeah, 0, I is less than k. So, okay. So what we want to do here is we want to, and we kind of want to keep updating our right index. So we're going to maybe make our right equal to left. Yeah, so we can just do that here. So we're going to make our right equal to left, and we're going to keep growing it until we go to the new location. Yeah, something like that. So basically, in fact, we can even make this, yeah, this instead. And the reason is because we're going to first increment our right and then read from the index. Yeah. So we're going to say right plus and total. Now we don't want to do this. We actually don't want to do this because then we can get out of bounds here. Like imagine if we start here, like we're going to get out of, actually, technically no, we can't ever get out of bounds in our first iteration. Actually, no, we could. Well, yeah, maybe you can, but whatever. I'm not going to worry about it. I'm just going to solve it in a way that avoids that issue. So right equals right plus 1 mod code length. Maybe this isn't necessary, but in either way, this will basically never ensure we never go out of bounds. So if we get to like index 4, we'll go back to index 0. Okay. And now we want to say total plus the current index we're at. So essentially here, if k is 3, we're going to start over, we're going to start, where do we want to start actually? Yeah, so we have this case, but we don't have the other case, right? So I think we want to start at 1 because it's the next 3 elements, right? So if this was like -3, then -3 would be here, and that would give us 1. But if we're at a positive number, like the next 3 or whatever, the left should always start at 1. Yeah. Okay. Because we're going to start at this number, and then the first element is always going to be this one over here. Yeah. Okay. So now we're going to make sure to have this like thing. And yeah, so k can be n-1. Okay, well, whatever. It doesn't really matter. So yeah, I think technically, actually, we can never go out of bounds here. Because let's say, so like if k, the biggest number k can be is 3. So we'll basically read this, then this, then this. So we'll never go out of bounds. Yeah, so actually, let's just see what happens. I actually don't think we need this. Okay, but we will need it in the future for sure. But anyway. Okay, so now basically the right should end up, let's see, right? Yeah, so the right will start here. It'll increase, increase, increase. So the right will be here, the left will be here. And then we'll have a total. And then we can put that into our array. So we can say result at index 0 equals total. And then we basically need to loop through the rest of these indices and move the left up, move the left to the right one and the right to the right one, get rid of the old value and add the new value. So let's do that. 1, I is less than code length. Okay. So we're going to get rid of the value that was at the left. So we're going to say total minus equals code at the left. We're going to move the left up, but we're going to ensure the circular property so we can do this thing that I was saying before. So basically, it'll just go back to 0. Now we want to move the right up. So we can do this same thing for the right. And now we want to read in the new value at right. And we want to store it in the result. Okay, and now let's return the result. So it's definitely a lot more complicated compared to an easy problem, but this is like the better way to do it. Obviously, if you want the easy solution for every number, just go to the right k times. And then, like I said, to make sure you don't have that out of bounds, you just do this. So your index just mods by code length, and you will, as soon as you're out of bounds, you start at the start. This is a little bit more complicated with one space, and we'll try to clean it up. Okay, let's see. Okay, looks like we don't have a total. We'll make it 0. Okay. Okay, so we're getting an error here. So let's print some stuff. Let's print result 0, and let's print the left and the right here, just to make sure we're getting what we expect. Yeah. In fact, we can even do like a format string. So left equals this, and then yeah, I forgot the format. I think it's like this. Right equals, or we don't need we just need the result 0 equals this. I think this is the format, if I remember correctly. Then we just give the variable, so this is like left, result 0. I guess we want the right as well, probably. Might as well. Okay, and then we can have the right here, I think. Let's see. Okay, so let's see. So what do we expect here? So the left should be here, which is correct. The right is at index 1. So k-2 is going to start here. No, so that's not correct. It shouldn't be at index 1. And this is 0 for some reason. Oh, right. So we want to just... So this is the problem. So because our k is negative, I think we're just not going in here at all. So we can just make k positive. So we can say... yeah. We can just say k equals absolute value of k. That's the problem. I think we're just not going in here. Okay. Let's see if we get the right thing here. Okay. So even though we're getting like a bad runtime, this is still going to be more efficient for like bigger numbers. But just like the way LeetCode tests are, it's whatever. So yeah, sometimes you can have like a worse solution in O of n complexity that will run faster on LeetCode just because we have a lot of these extra steps. So let's see if we can clean anything up. Like, let's see if we can handle this case without actually even doing anything. That might be a good idea. Okay, so if k is 0, we're never going to hit this loop. Yeah, so if k is 0, we're never going to hit that loop. And then basically, are we going to hit this loop? Yes. Yeah. So what's going to happen here is we're going to get rid of, like, left will be here, I think. Yeah, so this is going to get screwed up, I think. Although, if left and right move the same amount, then it won't get screwed up. But this will be kind of weird. I guess let's see. Yeah, so it does kind of handle this case, but it's kind of unexpected. I think it's because left and right are the same index all the time because your window is like length 0. But not super clear that is going to happen. How interesting. I guess maybe because I had a print line. Yeah. Okay. But yeah, so just to recap the idea here, basically for a number, we're figuring out like what's the left and the right start, or the left and the right bound of the window that's going to contain all the numbers we need. And then when we go to the next number, that window is just going to shift by 1 every single time. So we're just always deleting the left number, always adding the new number. So we don't have to like keep recomputing this sum. You could also do like prefix sums or some other stuff, but this is like the O of 1 space, like optimal solution. Just a little bit more complicated, I guess. And yeah, if I was doing like a LeetCode contest, that's why some of the downsides of a LeetCode contest are like you would just brute force this because you can do that code in like 2 minutes. So that's why this took a little bit longer. So this is going to be linear and O1. Yeah, I can probably clean up some other stuff, but hopefully you get the idea. Hopefully I explained it well enough. Let me know what you think about this format, and I'll see you in the next one. Thanks for watching.